Energy storage systems are extremely capable, particularly with the advancement of technology in power electronic converters. They're very versatile, they're very capable, they're very flexible. Associate Professor Behruz Bahrani. I'm also the director of the Grid Innovation Hub at Monash University. My background is essentially in electrical power engineering. The short answer to this question, whether renewable power can provide baseload, is yes. Certain renewable energy sources can provide baseload power, particularly geothermal, hydropower, or biomass. They can easily provide that, and they have been actually proven technologies in certain countries like Iceland, for example. You can look at that country, 100% is coming from these renewable power, and they provide baseload. But when it comes to intermittent renewables such as solar and wind, we'll have some challenges because of course they're variable, depend on weather conditions. In Australia, we potentially can use a combination of these technologies, these renewable technologies, to provide base load. In a state like Tasmania, when you look at it, a hydro-rich state, the majority of power in Tasmania is coming from renewables and coming from hydro, which is one of the best technologies for providing base load. Meaning that if we combine wind and solar with the likes of hydro, is obviously a fantastic choice. It can provide base load for us very well. Energy storage can help us significantly when it comes to wind and solar and any intermittent source of energy to provide the base load. So already we've got a number of sizable energy storage projects in Australia, the first of which was developed in South Australia a few years back, and that's still operational. A few other projects have been actually emerging in the past couple of years, 8 projects that were funded by the Australian Renewable Energy Agency. They will be bringing something around 2 gigawatt and 4 gigawatt hour of energy storage to the Australian grid. This is a huge amount of energy storage coming to our actually system. It will be a game changer when all of them are operational. AI and machine learning potentially can also help us. They're already in use for many different grid operators. Demand prediction and also generation prediction using advanced technologies can actually be very, very helpful in future years. While we're learning how to use these advanced techniques, we'll be phasing out traditional baseload power providers. And I believe it's relatively hassle-free journey, because the more advanced these techniques become, less reliable will become on traditional baseload power providers. Retiring our synchronous generators, which are the traditional sources of energy, we would require more advanced technologies such as grid-forming inverters, which are powered by energy storage technology, to form the grid, to help the grid to stabilize itself. The alternative of not going for renewables is actually very, very dark. In Australia, in Melbourne, we have had a number of storms in the past couple of months that they've been devastating. So we don't want them to actually happen more often. So I think the consequence of not going for renewables is actually very massive. We don't want to see more of these disasters. We don't want to see more of these, the effect of climate change on our society. So I think the cost of inaction, the cost of not doing anything is huge.